What is a set? It's a collection of objects. It can be finite or infinite. Now, to represent these sets, we use basically two ways. One is explicit representation, where basically we list out the objects that we are talking about, okay, explicitly. Okay, so every member of this set is present within a second bracket. Okay, sometimes what we do, if the set is quite large and we can't list all the elements one by one, then we use a shortcut, okay, that is known as set builders form. Okay, so for example, I am talking about real numbers. Okay, real numbers such that they are within this range. So all the real numbers that are within 2 and 5. Now the question is, how many real numbers are there? There are infinite. Okay, so if I start listing all the real numbers one by one like this, it's a problem. So for that, we use this notation. X belongs to the set of real numbers such that X is in this range. Okay, this is a symbol. Okay, it means belongs to. Okay, and this R, the regular R that you have, and you put one extra vertical line here, this means real numbers. Okay. So integers, fractions, okay, irrational numbers, everything comes under this one umbrella. Okay. Now anytime we introduce mathematical objects, new objects, so for example, you have been introduced to integers. Okay, the moment we talk about integers, we have to deal with some operations. It may be addition, it may be subtraction, whatever. Okay, because mathematical objects don't exist in isolation. Okay, it's binary. Every time there are two objects and there is certain operation going on between them. So similarly, if I have two sets, okay, there are certain operations that you can do within two sets. So for example, you can do union, you can do intersection, and there are many others, but today's the topic of discussion today is not, sets. In a way, we are slowly going to move to a different topic. So I just need some basic ideas from set theory to know, and we'll going to be building up on that. Okay, so our goal is not to know about every operations that there are. Okay, we just need the basics. So union and intersection are the two basic operations. Okay, so what do we mean by union of two sets? So for example, if I give you these two sets, A, B, C and D, and C, D, E and F. Okay, by the way, these objects can be anything. Okay, it can be letters in English, it can be letters in Greek, it can be integers, it can be real numbers, it can be fractions, whatever. So if I say that I am trying to find the union between these two sets, okay, union is represented with this symbol. Okay, and intersection is inverted U. So what do we mean by union of these two sets? So union means whatever elements that are there, okay, in the two sets, you take everything and put it in one place. Okay, this is the idea behind union. So if I go for union, what I have to do, I have to put everything in one place. Now, of course, you may be tempted to think that, okay, C and D is present here, C and D is also present here, so why not write C 2 times or D 2 times? But that's not the case. Okay, if there are repetition of elements, we just take one single element. We don't write the same element multiple times. Okay, so this is the basic of union. Now let's go towards intersection. So what if I give you these two same sets, and if I go for intersection? Okay, what should be the outcome? The outcome is whatever you have common in the two sets, the two participating sets, you just take those items. Okay, this is intersection. So with this idea, we want to go to our next topic, which is, intervals. Okay, so we have our set of real numbers. Okay. We know that we represent this set with this, line, okay, where we put 0 here. This is our positive infinity and this is negative infinity. Okay, so every number, every real number that can be there, it's present on this line. Okay, this line of infinite length. Now if I say that I take a portion out of it, okay, this is our interval. Okay, so there are two types basically. One is open, okay, and one is closed. So open interval means this situation where I say that x is less than 5 and greater than 2. Okay, so what we do, we basically take this whole real line, it's called real line, okay, because it represents real numbers, and say it's r0, 1, 2, 3, 4, 5. So we start from here, and so this chunk we take out. Okay, so this is our interval. Okay, now why is it called open? Because there is no boundary. Okay, you may think that, okay, 5 is the boundary, but 5 is not the boundary, because x strictly less than 5 means, okay, this inherently means that x can't be 5. So x can be 4.9, then 4.99, then 4.999, and so on. Okay, but it will never become 5. So before 5, how many numbers are there? Infinite. Okay, so this is the meaning behind open. Okay, so you can go forever, but you will still not be able to reach 5. And this is same for this direction also. So for example, it can be 2.01, okay, then 2.001, and so on, but it will never become 2. Okay, so that's why it's called open interval. Okay, And if I go for closed interval, then what we have to do? We have to do less than equal to and greater than equal to. Okay? It means that x is less than 5 or x can be equal to 5 also. Okay? So there is a specific boundary. That's why it is called closed interval. Now we can make combinations of these two. So for example, we can say that I have something called semi-open. So I can say that this side we write greater than equal to 2, but on this side it is strictly less than 5, or the other way. Okay. These are semi-open interval. Okay. Semi-closed, it's the same thing. Okay. Now, if you look at this whole idea of intervals, you will very soon notice this idea that intervals are nothing but sets. Okay, because this range is basically a collection of objects, right? Okay. By the way, there are certain symbolical aspects to this. So for example, you are used to this notation. Okay, so maybe if I want to represent this, there is another representation to this. So for example, I can write 2 comma 5 and put a first bracket over it. This means the same thing. Okay, and if I have to use this notation to represent this scenario, what we have to do, we have to just use third bracket instead of first bracket. So if I want to say that, okay, let's use this technique for semi-open intervals, we have to do this. Here we have to do this. Okay, always remember that whatever you can touch, you can put a third bracket on that side. So for example, if I say the whole real number, if I want to use this bracket notation, we can go for infinity and minus infinity, put a comma over here, but we never should use this, because you never can't touch infinity. It is such a large number that you can grow beyond it also. So it's a never ending thing. So that's why you should always put a first bracket when you are talking about the whole real line. In that case, it's an open interval. Okay, so this is a set, this is the whole set. These intervals are a part of this set. So let me introduce this new term. So our goal is not to discuss sets today, okay, but let's introduce these terms. So this is called subsets. These are called subsets. So you have a big set, you take some elements from it and you can call it a subset. Okay, so this interval is nothing but a subset of the whole real line. Okay, so as we know from the last page, that if I give you any two sets, you can do operations on them, okay, in between them, to be very precise. So I have shown you basic two operations, so union, intersection. Okay, there are others. There are set difference. There is something called complement, but let's not go there. We'll discuss those topics on a different day. Union and intersection is enough for today's discussion. So for example, if I say that I give you two sets or subsets on the real line. Okay, so I give you two subsets on the real line. So for example, one is this. Okay, and by the way, so suppose if this number is -5 and this is 1, if I have to represent this scenario, where I am talking about open intervals, I will put a bracket like this. If I want to say that, okay, I am talking about closed intervals, not open, in that case, I will put a bracket like this. Okay. Just a representation of things. Okay. Now, if I give two intervals or say two sets to you, can you talk something, can you talk about their intersections and unions? So for example, if I give you two sets like this, okay, or subsets, whatever, one is this and the other one is this. Okay. So if I say that you do a union between these two, what will happen? So if your x is within this range, okay, union automatically means that you are talking about OR. Okay. This is very important. Okay. So your x either belongs to this region or it may belong to this region. So whenever you are talking about unions, you are basically talking about this or this. So suppose you have seen these kind of problems. So suppose in a city, there is a set of people who read newspaper 1. Okay. Okay. Or a subscriber of news channel number 1. And this is another set of people who subscribe to news channel 2 or newspaper 2. Okay. So if I say, who are the people who say reads either newspaper 1 or newspaper 2? So if I go for OR, you automatically see that I am talking about this whole zone. Okay. But the moment I say that who are these people who reads newspaper number 1 and newspaper number 2, so the moment we ask about who are these people, that I am talking about this zone. Okay. Because this is the zone which is common to both the sets. Okay. So the people that belong here read both the newspapers. So it means that intersection inherently means and union inherently means OR. Okay. So if I am talking about this interval union this interval, so there is an OR. So if I say and in this scenario, okay, what you have to say? X belongs to this region and this region. So you will see that X is basically nothing, because X can't be in this zone and in this zone at the same time. Okay. If I say OR, okay, it can be here or here. But if I say X is, say for example, let's use some numerical number. So let this number be 5, minus 5. This is 1. Okay. This is say 3, and say this is 7. Okay. So if this is the scenario, if my X is within minus 5 and 1, it can't be at the same time within 3 and 7. So if I say what is the intersection of these two intervals, my answer is nothing. Okay. So in set theory, this nothing is known as null set. Okay. And it is represented as phi. It's a Greek letter. Okay. But if I say that I am talking about this kind of a situation, this kind of scenario, where you have your first interval like this, and maybe you have an interval like this. Okay, then and or intersection has a meaning. Why? Because there is a common zone. Okay, so if my x is within say -5 and 3, okay, so x is either strictly greater than -5. I have used first bracket, okay, because I want to say that my interval is open. So a first bracket, and that same first bracket is represented here. Okay. So -5 strictly greater than -5, strictly less than 3. This is the situation. And in this yellow interval, which is a semi-open interval, let's say this number is 1, okay, and this number is say 6. Okay, so x is not strictly bigger than 1, but greater than equal to 1 and less than equal to 6. Sorry, less than 6. So if this is the situation, then there is a common zone. So what is that common zone? If I go for intersection, what should be our outcome? Our outcome has to be bigger than 1, okay, but sorry, it is greater than equal to 1 and it is strictly less than 3. Okay, so this zone. Okay, so whenever I give you two intervals or two subsets, intersection will give you some result in the form of another interval only when there is an overlapping zone between the two given intervals. Okay, only then intersection has a meaning. Otherwise it will be a null interval or a null set, and it will be represented as 5, okay, using this symbol. So these are some basic ideas from set theory that we need to discuss what we actually want to discuss today. Okay, so for that, let me go to a new page and start today's class or discussion with a very simple problem which looks like this. So by this time I hope you know about these symbols. Okay, greater than, equal to, less than, equal to, strictly less than, strictly greater than. Okay, so my question is this. Okay, now if this question was, the actual problem is this, okay, but suppose you are in a you are in grade 9, okay, and you have seen this problem before. Okay. This idea of greater than, equal to, less than, strictly less than, these ideas are new, fairly new, but you are quite familiar with this. Okay. So there is some familiarity with this problem. So if I give you this problem, you will very quickly do these things. So you will go for x plus 3 equal to 2x minus 4. Okay. Then you have x and 7. So you know that 7 is the number. If I put it here, this number satisfies this equation. So this is equation, okay, or equality. This is something that we call as inequality. Okay, because it is either this or this. So it may be equal or it may not be equal. So that's why in general we call these things as inequalities. Okay. But you have solved equations, there is no doubt. So this is the solution. Okay. So this is the solution of this equation. Why? Because if I put my 7 here, you get 10 over here, and you have 5 over here, and 10 by 5 is equal to 2, which is fine. But if I start with this, this notion, and we are trying to apply this idea over here, and we do this same thing, x plus 3 less than equal to 2x minus 4. Okay, then very quickly we can see that x is greater than equal to 7. So if I reach this conclusion that x is bigger than 7, okay, so if this quantity has to be less than equal to 2, my x has to be bigger than equal to 7. Okay. If this is the only conclusion I am reaching, okay, is there some problem with that? Let's test this theory. So for example, if I go for bigger than 7, so let's take 9. Okay, so you have 12 upon 7, right? X is 9, so 9, 3, 12, and 7. This quantity is 1 point something, which is less than equal to 2. So we are fine with this. But if I go on using numbers higher than 7, every time we take certain x which are bigger than equal to 7, we'll see that whatever quantity we get, it will be less than equal to 2, which is our requirement. But my question is, do you have certain so for example, if I go for -5, okay, so if I go for x equal to -5, so in that case, what is the situation? I have -5 plus 3 divided by x minus 2, -5 minus 2, which is -2 by -7. So of course this quantity is 0.2 and something. Okay, so once we are saying that if this condition, if this quantity has to be strict, I mean lesser than or equal to 2, if this is our requirement, for that x has to be bigger than or equal to 7. But I have just shown you that if I take -5 as x, which is not bigger than or equal to 7, it is much lesser than 7, still we see that our condition, that this expression x plus 3 by x minus 2, we just calculated this expression for -5, as you can see. So we have put -5 in place of x. So -5 plus 3, -5 minus 2, and this ratio ultimately turns out to be 0.2, which is again less than equal to 2, right? So why is this thing happening? Okay, what have we missed? Okay, so you take some 2-3 minutes and tell me that what genuine or serious mistake have I made to miss this. So I will tell you multiple other values of x which are not bigger than equal to 7, but if you put that value in this expression x plus 3 by x minus 2, you will see that okay, fine, the conditions that the condition that we are seeking, okay, that this expression is less than equal to 2, it is still being met. So it feels like we have reached a conclusion which is true but partially true. So we are missing something. Okay, so something is missing. Right? So what is this missing link? The answer to this problem or this confusion is a very basic idea, okay, that you know already, okay, but maybe you have missed it. So for example, if I go for 5 is bigger than 2, I know that I can write 10 is bigger than 4, right? Just like if I say x is equal to 2, I can say 2x is equal to 4. So if I give you some equality, you can multiply the whole equality by 2. Okay, If I give you some inequality, you can also multiply that inequality by 2. But here is a catch. So if I go for x equal to 2, and which implies 2x equals to 4, there is no issue. Okay. And this also implies that minus 2x will be equal to minus 4. So you can multiply with minus 2 also. But the issue is, if I do this thing, if I do this same thing with some given inequality, okay, then there is something interesting happening. So for example, if I go for minus 10, so you are multiplying it by minus 2, so you get minus 10, okay, and you get minus 4. But if I say that this inequality, the direction of it, okay, this remains the same, there is a problem. X plus 3 by x minus 2, I had x plus 3 by x minus 2 less than equal to 2. So from here, if I am trying to write x plus 3 less than equal to 2x minus 4, and then we have proceeded, right? So what is happening here? What is the step? Okay, what did we do here? So the step is, we have multiplied the inequality by x minus 2. So I have done this basically. Right? Then this cancel out, these two cancels out, and we have this. So if I have multiplied this inequality by x minus 2, do we know something about the sign of x minus 2? The answer is no. We just blindly multiplied the inequality by x minus 2. This is our mistake basically. So it means, to correct that mistake, we have to do these things. So for example, x minus 2, if it is positive, then what? If it is negative, then what? We have to consider these two cases individually, as we have blindly just multiplied by x minus 2, and we have never taken into account the change in the direction of this inequality. We forgot to flip this inequality. If it was the requirement, we didn't do this. So that's why we were getting some partial answers. So if I take this into account, and you branch out into these two cases, so when x minus 2 is positive, then what? Then x plus 3 by x minus 2 less than equal to 2, I can multiply it by x minus 2, so x plus 3 becomes less than equal to 2x minus 4, okay, and x becomes greater than 7. This we got earlier, but what we missed was this scenario, where we had to after the multiplication by x minus 2, we had to flip this sign and write this maybe, right? So we didn't do that. Okay. Now if I do this now, still there is some confusion. You may think that, okay, x is less than equal to 7, so x is bigger than equal to 7, x is lesser than equal to 7, okay, these two are contradictory, right? And which is kind of weird, right? Once I am saying that no, x has to be bigger than equal to 7. Once I am saying that no, x has to be lesser than equal to 7. So these two things are, they just contradict each other. But in actuality, it does not. Why? Because think about this. Can x minus 2 be positive and negative at the same time? No, right? So if this is the case, then here is a OR, right? So either x minus 2 is bigger than 0, okay, which means x is bigger than 2, or x minus 2 is less than 0, or x is less than 2, okay. Or starts from here, right? So x can't be bigger than 2 and lesser than 2 at the same time. So either this is the situation or this is the situation. So if I am reaching this conclusion that x is bigger than equal to 7, we are reaching this conclusion only because we started from here, okay, which means that if this is our starting point and this is our conclusion, here is an inherent AND present. So we read it like this: if my x is bigger than 2, okay, then my x can be bigger than 7, okay. It right now, for the moment, it sounds a little weird, but it will make sense, shortly. So these two things are happening at the same time, or these two things are happening at the same time, okay. So there is no contradiction actually, because this and this are not happening at the same time. There is a branching out. Basically, these two things are completely separate. I hope this is clear. Now if this is the case, let's start drawing our intervals, okay. So let's start with this. So suppose this is my real line. Here I have 2 and here I have, let's say, 7. So what am I saying? I am saying that if my x is bigger than or equal to 2. Now here is a catch, okay. X minus 2, you don't have to bother about it being equal to 0. Why? Because x minus 2 is not 0, okay. Why? Because it's here. So if my x minus 2 becomes 0, then this becomes a problem, huge problem, because you can't divide something by 0. So there is a correction, small correction. So these corrections are, you find them as you go. So you don't need to bother about x being bigger than equal to 0, and this side also x being lesser than or equal to 2. 2. Okay? X minus 2 being lesser than equal to lesser than 2, and x less than 2. This is enough only, because you don't need x equal to 2, because that will disturb this expression. So what I am saying now, I am saying that if my x is strictly bigger than 2, then x has to be, okay, because these two things are happening simultaneously, okay. So newspaper number 1, newspaper number 2, okay, these two has to happen simultaneously. So which means you can draw a first bracket like this, first bracket and the extension, okay, to mention that, okay, I am starting with all the real numbers that are strictly bigger than 2. But then if that is the case, simultaneously this has to be also true, that the number has to be bigger than or equal to 7. Now the moment I draw these two regions on the real line, you will see that if I talk about this region, okay, So this region. Okay, this region contains the numbers which are strictly bigger than 2 but lesser than 7, right? So if I want to have the real numbers which are strictly bigger than 2 and bigger than equal to 7, then we have to go beyond the bigger number. Okay, so we have to say that this actually means that I am not talking about this zone but this zone, because this interval and this interval, okay, these two intervals have a common overlapping area. X is strictly bigger than 2. This can be written as this open interval. Okay, strictly bigger than 2, it means that there is no upper boundary here, and bigger than equal to 7 means that this upper boundary of infinity is also here. So this situation can be written as this, semi-open interval. So if I try to describe this situation in a using say theoretic notations, then what I have to do, I have to say that 2 infinity union 7 infinity. Okay, now we have two numbers, 2 and 7. This is the bigger, this is the smaller. So if I want my x to be strictly bigger than 2 and bigger than or equal to 7, I can't take a number here because this is lesser than 2. I can take a number only here, because in this region what will happen, my number will be bigger than 2, that part is okay, but it will be lesser than 7. So whenever I am trying to write an AND statement, so for example some statement 1 and then some statement 2, and if I try to write AND in between, the whole thing is true only when they are individually true. Okay, so if I take a number in this region, okay, x being bigger than 2 holds, but x being also bigger than or equal to 7, it doesn't hold here. Okay, so eventually this union operation will give you 7 comma infinity. This is the final result. This side, on the left hand side of this. Okay, so if I go for this case, okay, where x is less than 2 and x is less than or equal to 7, we have to do the same thing. Here it is 2 and minus infinity, okay, because it is lesser than 2 and it has no boundary towards the left, and here also it is lesser than or equal to 7, and on this side it can go till minus infinity. So what we are essentially doing, we are taking the union of it. So minus infinity to 7 union minus infinity to 2. Okay, so here is my 2, here is my 7. I am talking about lesser than 2, strictly lesser than 2, so this region, and lesser than or equal to 7, so this is the region. So I have to go for the common area between the white and the yellow. Okay, so eventually if I go for this union operation, this is the smaller quantity among 2 and 7. So if I have to go for lesser than 2 and lesser than 7, I have to make sure that I am lesser than 2 only, because otherwise if I pick my x from here, okay, it will be less than equal to 7, so that part will be okay. But we came to this conclusion only when we started from here. So if I take a number from here, it will be lesser than equal to 7, but it will be not less than equal to, not less than 2. Okay, that's why this region we have to discard. This is so we absolutely have to discard. So the only acceptable region for x is this. Now if I juxtapose these two sides into a so what we are essentially saying that here is my 7, because we have seen that this union operation between these two sets leads me to bigger than equal to 7, less than equal to infinity. Okay, or okay, so the or is written somewhere in between. So this is the zone, or this is the zone. Okay, so this minus infinity to 2 is not present, so it is less than 2, and 7 or bigger than 7. So there is this or in between. Okay, so x can be either this or this. Okay, if you remember few slides before, I have talked about this situation. I guess, yeah. So I told you that if your two intervals are they are separate, this situation is called disjoint. Okay, we say that these are disjoint intervals or sets, maybe. Okay, because intervals are nothing but sets, so they are separate. Okay, so if I try to find something common in between them, nothing is common, so it's fine. But if I have to say that okay, this or this, I have to take this and this also. But technically we are saying that this and this, but it is this or this. Okay, so x can be either in this in this zone or in this zone. So I was trying to introduce these notations on the real line intervals just because I wanted to use these notations here. This. Okay. So now you look at it carefully. This was the original problem, right? X plus 3, x minus 2 less than equal to 2. This was the original problem, and we got some partial answer to this, that x has to be bigger than or equal to 7. So what did we miss? We missed this part. Okay. This is the thing that was missing. Okay, that's why when I told you that, yeah, here. So when I told you that if I am saying that x is bigger than 7, that is the absolute prerequisite for this expression to be less than or equal to 2. But why are we getting the same thing, a fraction which is less than or equal to 2, even when we put something which is not bigger than equal to 7? So this is no magic. Okay, it's no magic. It's just that in our calculation we didn't take into account of this situation, of this case, the right hand side. So now you can say that okay, fine, this is something that we missed. That's why when I said minus 5 in place of x plus 3 by x minus 2 took you to this fractional value, which is okay. Okay, now look at this. X being minus 5 is absolutely in this region, right? So minus 5 is somewhere here. It is on the left hand side of 2, right? Now if I tell you that take some number within this area, okay, so starting from, so this side you have something less than 2. So whatever is on the right side, it has to start from this. So we have to take 2. Okay, so towards the left you are not taking 2. Okay? Everything is strictly less than 2, but to the right you have to start from 2, right? And here you have taken already 7. Okay, so 7 or bigger than 7. So this side it has to be what? First bracket 7. So this is the zone which is in between. Okay, 7 included here, so not included here. 2 is not included here, that's why included here. So now if I say that, okay, let's pick some number 3 and then try it out. So x plus 3 and x minus 2 becomes 6 divided by 1, which is 6, which is not less than equal to 2. So if I pick some number in this zone, see, the inequality that we are asked to solve, it breaks. Okay, so this is the idea. Now the question is, the fundamental idea is that if I am given such a simple problem, do I need to every time use these many pages, case by case? What if this quantity is positive, what if that quantity is negative? Do you need to do all this hard work, or is there some other shortcut method? So that shortcut method is very simple. Whenever you see some constant which is not 0 present in some inequality, you get tempted to do multiplication, right? And then all the problem starts. All these hazards of taking into account for the sign of x minus 2 and all these things. You get into these problems just because you are being tempted to do multiplication first. Okay, what if I tell you that you go for this? This is the safer option, because subtraction is a simple process, right? So to take 2 from right hand side to left hand side, there is no case. It can be done every time, okay, without any partitioning it into different scenarios and cases and all. This can be done. So after this you can take LCM. Okay, you can go for x plus 3 here, then minus 2x plus 4 here, and you have less than equal to 0. Okay, and then finally this becomes 7 minus x and x minus 2, which is less than equal to 0. And if you think that, okay, I don't like 7 minus x here, what you can do, you can just put a minus sign over here, and maybe you can make it x minus 7. And then be careful again, you just don't multiply by minus 1, but you take this quantity to the right hand side. Okay, because multiplication means again you have to flip this direction of this inequality. You don't want to do that, you just take this to the other side. So eventually this becomes x minus 7 over x minus 2, and it is now bigger than equal to 0. Okay? So this whole thing goes to right hand side. So the idea is that whenever you are given some constant which is other than 0, and you are being asked that whether this quantity is lesser than equal to this or bigger than equal to this, whatever may be the case, you can convert this problem into a let's say 0 constant problem, let's say. So now your whole goal is to check the sign, not the value. Okay, so your goal is to find whether this quantity is positive or negative. Now if you start by observing this phenomena, that okay, I have given that this quantity has to be bigger than or equal to 0. Okay, So this is a very serious thing. So if our given inequality didn't have this equality here, then you had to make sure that x is not equal to 7, right? So these small changes, these small nuances are worth noting, because if it is strictly bigger than 0 and not 0, this quantity on top, it can't be 0. Okay, but as in our problem this equality is given, this is not so important, so x can be 7. Now the question is, I am to find the sign of this quantity. So what can happen? Okay, I have given you a ratio. Okay, there are basically 4 options if you think about it. So one option is plus over plus, right? One option is plus over minus, then maybe minus over plus, and lastly minus over minus, right? You know that this situation will lead to a net positive sign. This situation and this situation will lead to a net negative sign, and this situation will lead to a net positive sign. So if I am trying to find the situation where for which values of x minus 7 over x minus 2 is positive, I have to look for 2 situations only. So one is either x minus 7 is positive, okay, and x minus 2 is positive. So now look at this thing. X minus 2 is below, so it can't be 0. That's why here the equality is allowed, but here it's a strict inequality, because if x is 2, then something by 0 appears, so you can't allow it. So this is your one option, okay, option number 1. So it is 0 or bigger than 0, because it can be 0, and this is strictly bigger than 0, so plus by plus kinda. And the other option is minus by minus. So in that case you will say that x minus 7 can be 0 or less than 0, because 0 it can be, always be, because otherwise this equality was not, it shouldn't have been there. So if this is the situation, and simultaneously this is also the situation, so plus upon plus and minus upon minus, so this is your goal. So if you look at this, now you will get the same thing, okay, x bigger than 7, bigger than equal to 7. Here I have x bigger than 2, here I have x less than equal to 7, and I have x strictly less than 2. So if you think about it, it's the same result that we have seen earlier. Okay, x is bigger than 2 and bigger than 7 on this side, x is lesser than 2, strictly lesser than 2, or lesser than equal to 7. So it's the same result, but in this approach you had to look at so many things, you just skipped all those hard labor. Okay, we say that okay, my final answer is that x is either 7 or less than infinity on this side, union strictly less than 2, strictly bigger than minus infinity. So you can do all these things in just one page. Okay, so this is the idea. Okay, now from here onwards, I think I need to introduce you to some other operations between set. So set operations again. So we have seen union, okay, you have seen intersection, okay. Now there is something called set difference, okay, or difference maybe. So two sets A union B, we know what it is. So whatever in A, whatever in B, you put it everything in one place. If you see that there are things common to both the sets, you don't repeat those items. And we also know that what A intersection B means. Okay, so it's a common elements. Okay, difference is something, and if I try to show this idea with Venn diagrams that you have seen. So union means the whole thing. Okay, intersection means the common region. What do we mean by set difference? What do we mean by A difference B? Okay, so A different B is this. So if I look at this Venn diagram, if this is my A, if this is my B, A difference B is this region. So you take A, okay, whatever in A is an element of B, you just remove it from A. So you take only the part that is exclusively A. This is what we mean by A difference B. And if I go for B difference A, so A difference B is this region, B difference A is this region. So whatever in B is also in A, you need to leave them out. Okay, so this is the whole idea. Now there is one another set operation known as complement. So there is another operation which is complement. Okay, so for complement we need to know about something called universal set. Okay, and this is really contextual. Okay, so for example, if I am talking about some interval on the real line, this real line or the set of all real numbers symbolically represented by this notation, this set of all reals becomes the universal set for this subset or this interval. Okay, so for example, all newspaper readers. Okay, so this is a set of newspaper readers. Okay, so this is the universal set within the context that I am talking about telegraph, maybe I am talking about Anand Bajar. Okay, maybe I am talking about Times of India. Okay, so these are sets. In this context, we mean the whole set of newspaper readers, in a city or maybe in a state or maybe in a country. So this is our universal set. Okay, so if this is my universal set, and if this is some set within that universal set, and if I call it A complement is this region. Okay, so this region is A complement, written as a small c over A or A bar, whatever you prefer. Okay, so this is A complement. Now as we are trying to discuss intervals, because our sets in question are intervals only, so their union, their intersection, their differences, this is not that important. Sometimes it may help, sometimes it may not. Complement, how we use these operations in terms of when we take our sets as intervals. So let's look at some certain example of that. Okay, certain examples of that. Suppose I am trying to ask you that I have given you this set 2, 3. Okay, so what if I am trying to find the complement of it? Find the complement of it. If this is a question, then 2 here, 3 is here, 2 you can't touch. Okay, even though I am touching it, but this first bracket kind of an drawing makes this certain that we are not touching 2. Okay, and on this side we also do the same thing. So this is what we are talking about. Now if this, the whole real line, is my universal set, so if I ask you that find the complement of this, what will you do? Okay, so from this side, this portion you need, and from the right hand side, things bigger than 3, you need this. So 2 you couldn't approach from the right, but you can approach it from the left. So you are trying to say that, okay, this is what we are trying to do. So this is your region, or here x is bigger than equal to 3 and less than infinity. So this region here. So if I ask you what is the complement of this interval, it's this. Okay. Now small variations. So if I start with third bracket here, first bracket here, what will happen if I go for complement? Wherever you see a third bracket, you have to put a first bracket. Wherever you see a first bracket, you have to put a third bracket. So this is the complement. Okay. If I go for this, vice versa, you know what to do. Okay. If I start with a closed interval, okay, if I ask for complement, then both the things will be first bracket now. Okay, I mean these are not brackets, but you can think of it like that. That you have a bracket, and then from that bracket you have this extension. Okay, so this is the use of complement. What about set difference? How to use difference? So for example, I can also, if I am seeing some interval, so I can do minus infinity, then 2, union here 3 and infinity. So if I want to save some space, I can just say that using complement, I can say that 2, 3 open interval complement. This is one way of representing it. Okay, because we are talking about MCQ exams, so A, B, C, D, 4 options maybe. So you have reached this idea, reached to this conclusion that this is my answer. But you see in the option D, 2, 3 complement is written. So you have to know that this and this is the same thing. These two are not different. Okay, and if I try to write it, using the set difference notation, I have to write R, so the whole real number, difference, or sometimes it is written like this also. So R difference open interval 2, 3. This also means that excluding this open interval 2, 3, first bracket, this combination, apart from this, whatever is present on the real line, you take everything. Okay, so apart from this region, whatever is there, you take it. Okay, so this same thing can be represented using complement also, like this way, or you can use the idea of set difference here, because you will see when you start solving questions, you will see that sometimes these long things are shortened to some differently looking version. So you have to know everything. So now from here onwards, what will we do? We'll go for even further complicated versions of this simple problem. So you know that whenever I give you this kind of a problem, it ultimately converts to something like this. Okay, so 2 items. Okay. So what if I tell you that let's make it complicated? Okay, so complication number 1, I add more factors like this and ask you that when this quantity will be bigger than equal to 0. Okay, so suppose this is question 1. Okay, this is one layer of complication. Okay. You want to complicate it even further, you may say that okay, I have some factors, okay, but then let's say I have a 2 here, you know, okay, or maybe I have a 5 here, and let's keep it as it is. Okay, so just some constants, you know, being multiplied to these x's. Okay, you can complicate it even further, so you don't change this factors, but you put different powers over it. So let's say 3, 2, 6, 5, 4 randomly. Okay, and then in all these cases I am asking you whether this quantity will be positive. I mean, I can flip it if I want, but let's say, you know, we are asking this question. So these are the possibilities that you may see. Now see, technically if I you know, tell you how to tackle the most complicated version of this same problem, you know, the simpler versions you can, you know, easily handle. Okay, so I will go directly here where you have some constants, you know, multiplied with your x's, and then you have the powers, you know, everything at one place, all sorts of problems, you know, that you can see. Everything is in one place. So what we have x minus 7, then x plus 3, 2x minus 1, x plus 3, 2x minus 1, then I have 5x minus 2 and x plus 5, 5x minus 2 and x plus 5, and the powers are 3, 2, 6, 5, 4. 3, 2, 6, 5, 4. And the final thing is that I have to find that when this quantity is 0 or bigger than 0. Okay, you know now that I can change this if I don't want it. Okay, I can put it. Okay, it doesn't matter. So if I remove this equality, I just have to make sure that x can't be 7, because the moment x is 7, this is 0. The moment x is minus 3, this is 0. The moment x is half, this becomes 0, so it can't be half. Okay, I mean, if I remove this line, now it is present, so x can be 7, x can be minus 3, x can be half also, but here you have to look at carefully that x can't be 2 by 5, you know, then we have 0, x can't be minus 5. So these things you first, you know, look at this expression, and you know, these are your first findings. Okay, now after you have done everything, what next? So you have to look at this situation. So I know that you have seen that x minus 7 is a thing, and maybe x plus 7 is a thing. Okay, so all I am saying that you forget this minus and plus, the differentiation between these two cases. Even though you see a plus in between, what you do, you write it as x minus minus 5. Okay, so that you can form a general template like x minus alpha. Okay, alpha can be positive, okay, in this case, or negative, but x minus alpha is the thing. Now if I generalize this, like this, then the benefit of this is you can very quickly say if my x is bigger than alpha, then x minus alpha is greater than 0. If my x is lesser than alpha, not infinity but alpha, then x minus alpha is less than 0. These are direct consequences of this. So what you do now, you first find the alphas. Okay, so here you have your alpha as 7, then you know your alpha is minus 3. Okay, then you know your alpha is half. Now this is the thing here. Whenever you see things like this, you can take 2 out and it will become this. So if I have 6 here, 6 will be become, no, 6 will be the power of this also, and 6 will come here. So this actually, do not impact, this does not impact the sign, right? So 2 to the power 6 is always positive, it has nothing to do with the sign. So your alpha is this. That's why I was stressing upon x minus alpha. That's why I was stressing upon keeping this sign here as negative. This is the reason. Now you know all your alphas. Here it is 2 by 5, here it is minus 5. So what to do next, right? So the next idea is you have to arrange them. Okay, it is not necessary, okay, but it will be of tremendous help. Why? So that you can put your alphas in an increasing order. So for example, what is the smallest of these things? Okay, the smallest is minus 5. So you put minus 5 first, then what? Then you go for minus 3, then you go for 2 by 5. Why? Because it is 0.4. Then you go for half because it is 0.5, and lastly you go for 7. These alphas, let's call it alpha 1, alpha 2, alpha 3, alpha 3, alpha 4, alpha 5, because we have 5 factors. You have to arrange them. Now what is the benefit of this? The benefit of this is minus 5, minus 3, 2 by 5, half, and 7. Now if I am asking you to list all the factors here, so for example x plus 5, leave out the power first. Okay, x plus 3, then you have 5x minus 2, okay, and then you have 2x minus 1, and then you had x minus 7. So if I try to make a chart like this, what you can do, okay, you can start writing the signs. Okay. So maybe I just so you are moving with your x from left to right. The idea behind this arranging is so that you can you can look at it like this. So my x is lesser than 5, okay, minus 5, then it becomes bigger than minus 5 but less than minus 3, then it becomes bigger than minus 3 but less than 2 by 5, then it becomes bigger than 2 by 5 less than half, then finally becomes bigger than half and less than 7, and at the extreme end my x becomes bigger than 7. I arrange it like this. What I can do, I can say when I am my x is even lesser then the least of all this, all my signs should be negative, right? So if x is less than 5, let's look at this. If x is less than minus 5, of course x plus 5 will be less than 0, direct consequence. Now if I am less than minus 5, I am automatically less than minus 3, na? I am automatically less than 2 by 5, I am automatically lesser than half, I am automatically lesser than 7. Okay, so if x being lesser than 5, minus 5 leads to this, automatically x being lesser than minus 3 will lead to this, na? Okay, so you see every expression that I have written here, okay, it will all be negative. Now the moment you jump from this zone to this, you know that this minus will now become positive. Why? Because you have crossed the boundary of minus 5. So if my x is minus 4, x plus 5 will become minus 4 plus 5 equal to 1, which is positive. So this, among all these negative signs, only the top one will convert into positive, but all the rest signs will be the same. So the actual benefit of arranging these numbers, with time, with practice, you don't need to actually rearrange these numbers, but when you are learning it for the first time, this arranging these numbers in a particular increasing order has this benefit that you can fill this chart very quickly. Okay, so first it is all minus, in the next column it is only plus here. Okay, then these two are pluses, so you can fill it quickly. Then these three are pluses. Okay, and then finally 1, 2, 4 this, and lastly plus 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 plus. Everything is positive. Because why? Because if my x is bigger than 7, x minus 7 will be positive. So if my x is bigger than 7, the biggest one among this all quantities, so of course x will be bigger than half, of course my x will be bigger than 2 by 5, of course my x will be bigger than minus 3, and so on, right? So then in that case everything will be plus. So up until now what I have done, I have just taken the factors. Okay, now what? Now I have to look at the powers. Okay, 3, 2, 6, 5, 4. So maybe okay, so the smallest is minus 5, so 4 comes first. Okay, then 2, then 5. So 4, 2, 5, half is 6, and then 3. Okay, because you have arranged the factors, right, in an increasing order. You have to take the corresponding powers of those things. You can't just randomly go 3, 2, 6, 5, 4. You have to go 4, 2, 5, 6, 3. Okay, and then you write it here. 4, 2, 5, 6, 3. Okay, 4, 2, 5, 6, 3. Yeah, that's fine. So these values are not important. What is important is this thing, that these integers, whether they are even or odd. Why? Because as you know that this expression, okay, is negative here. Okay, but as 4 is a even number, this negative sign will be eventually becoming positive, right? Here you have 2, again even number. So if I take some negative quantity and I have power of 2 over x plus 3, it will also become positive. Okay, so in every column we are making two sub columns. Before, on the left hand side, we didn't consider the powers. Now on the right hand side, we consider the powers, whether they are odd or even. Here you see you have 5, so odd number, so negative quantity, odd power, it will become negative. Okay, it will stay negative rather. Here it will become positive again, and lastly it will be negative. So this column is your essential column. Okay, why is it so essential? Let's write it here. X minus 7, x plus 3. I had 2x minus 1, I had 5x minus 2 and x plus 5. 5x minus 2 and x plus 5, and the powers were 3, 2, 6, 5, 4. 3, 2, 6, 5 and 4. Okay, these are the numbers. Now we have arranged it according to our conveniences. So technically 5 minus 5 comes before. Okay, even though if I look at it like this, okay, in this order, it's last. So you don't really need to move it up here, okay, because then it will be a problem. Because technically in your given problem, x plus 5 is here. So if I put it here, it means that x can be minus 5, right, which is not the case, because you have to make sure that x plus 5 is in the denominator. So that's why you have to make sure that this quantity doesn't become 0. So if I just say that, okay, fine, I can see x plus 5 in the beginning here, I will just write it here, it will be a problem, it will be a mess. So you don't need to bother about it, but maintain this structure. Okay, maintain this structure, put a line here, okay, or maybe even a smaller line, and look at this thing. Okay, first quantity is x minus 7, come here. What is the original sign? Minus, right? Then what is the next item? X plus 3, go here, look at the sign, plus. Okay, then you have 2x minus 1, so come here, it is plus again. Okay, so while writing this, you have arranged this number in a sequential way, these numbers in a sequential way. Here you are following the structure that was given to you in the problem. So minus plus plus, okay, then we have 5x minus 2, so you have to come here, so it is negative, and then finally I have x plus 5. Of course you have to the power 4, you have to the power 4, which makes it positive, so positive. Okay, so you have multiplication of these quantities and division. Of course you have to take the ratio, but you have done all these calculations for this sub column only, right? So when your x is strictly less than minus 5, only in this values, only for these values of x's which are strictly less than 5, minus 5, in that zone, this is the idea. Okay, and all these signs are distilled here, and you know now that plus plus plus, minus minus eventually makes the whole thing plus, right? Because you have two minus signs, so they will cancel out. Okay, now you go for the same thing, you have to maintain the order. So 7, 3, half, so 7. So okay, fine, so let's take into account for the signs here also. So plus even plus, okay, minus even plus, minus odd minus, minus even plus. So I am intentionally making these signs, the right sub column, using a different color. And lastly, you have minus odd minus. Now you look at this expression. So 7 3, you don't need to bother about that the number is minus 3. You just read it like this: 7 3 half 2 by 5 and 5, okay, not minus 5. So that you can go for 7 3 half 2 by 5 5, okay. So 7 3, so 7 3, so minus plus, okay, then half, which is plus again, and then 2 by 5, and then lastly x plus 5, which is plus here, so plus. So you kind of calculated, decided upon the signs of these individual quantities, okay, not the values. Values are not important, just the sign, okay, and you have put it over here. So the same thing, okay, there is no difference, it is still positive, right? I hope I have not done any mistake. So let's check it once again. So 4 half, positive 4, negative 2 plus, negative 5 minus, negative 6 plus, negative 3 minus. No, it's fine. It's fine. Okay. See, the issue is this ordering is not that important. You can just put all the signs randomly, but I am stressing upon it. If you are doing these things for the first time, I don't want you to go for this mistake that accidentally you think that this is here and this become this here, okay, because that will be a mistake. Because if my x plus 5 is in the denominator, I have to make sure it is not 0. So to make sure of that, I am stressing upon this order. It is not actually important, because see, if I don't follow the exact right order, minus plus plus minus plus, if I just write it randomly, okay, still we will be able to get the sign, right? Because if I write this minus here and this plus here, okay, minus 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 cancels out. That is also true. Minus into minus is still positive, right? So it doesn't make much of a difference, okay. So you can do it even more faster. That's what I am trying to say. So again, 4 plus plus plus. So you have to only look for the minus signs. This is also a thing of which is noteworthy, because plus, if you take odd power or even power, any positive quantity, if you take even power or odd power, it will be always plus. The fundamental change which is happening here is to the negative sign. So here you have odd power, so negative stays negative. Here again you have positive, okay. Here you have negative, okay. Still we are out of luck. We have 3 pluses and 2 minuses. I am not wasting time here. So 3 pluses, write it in random order, it doesn't matter, and maybe minuses, 2 minuses, right? So it will be positive even here, okay. So positive positive positive. Now let's see if we can try some luck and make things negative. So is it possible here? I guess so. So here, so these pluses will be staying pluses, there is no issue. Among these two negative quantities, you have 6 here and you have 3 here. So this minus will become positive and this minus will stay negative. Now you see there is a single minus, everything else is plus. So this minus will not cancel, it will stay minus. Okay. So this is your column number 1. Okay, this is your column number 2. Okay, this is your column number 3. Okay, so less than minus 5, less than minus 3, bigger than minus 5, less than 2 by 5, bigger than minus 3, this zone. And then finally for this interval 2 by 5 and half, I have a net sign of negative. Okay. Then this is 3 odd number, this is negative. So here negative odd number will be negative, all the rest of the items will be positive. So here it will also be negative. So this is column number 1, 2, 3, 4, 5. Okay. So the final sign is circled over here. Okay. And lastly, everything is positive, so we don't need to really bother about anything. So remember what was the question in the beginning? The question was, for what, for which values of x's this quantity become 0 or bigger than 0. Okay? So either it is positive or it is 0. Okay. Now the answer is in front of you. Okay. You can check, here it is positive, here it is positive, here it is positive, and here it is positive. Right. So you look up and say that less than 5 works. Okay. Less than 5 means this side you can go till negative infinity. Then minus 5 to minus 3 seems to work. Then minus 3 to 2 by 5 seems to work. Okay. Then this doesn't work, this doesn't work, and then beyond 7 works. Okay. Now this is not the final answer, there are many things to notice. So for example, now you have to finally look at this, that x plus 5 can't be 0 because it is here, right? So I have to always use first bracket, okay, but x plus 3 is here, right? So it can become 0. So maybe this first bracket needs to be converted to a third bracket, right, on both the sides. Now technically, if beyond minus 3 and less than minus 3 and including 3, is 3 is included in both the sets, both the intervals, minus 3, not 3, I'm saying it wrong every time. So minus 3 is present in this interval and in this interval. So eventually what we are trying to do, we are saying that x has to be either in this zone or in this zone or in this zone, not in this zone, not in this zone, or in this zone. So every time all these subsets or intervals, whatever you want to call them, we are basically trying to take the union of these things. Okay. Why? Because or x is present here in this region or in this region, or it's never and, because if I say that this is my region, x is in this region, we at the same time belong to this region, right? X can't belong here. Why? Because these two things simultaneously can't happen, and means when two things are simultaneously happening. So a gentleman reads Times of India and Telegraph. Okay, it means that he reads both. Okay, so you have to go for union because it's or. Now the fun part is that minus 3 is common to both the intervals, so we can join them. Okay, so we can say that start from minus 5 and end at 2 by 5 and take everything in between. Okay, so that way, things lesser than minus 3 itself, and things bigger than minus 3, everything is kind of in a same thing. You can't do it for minus 5 here, because minus 5 is not to be meddled with. X can't be minus 5. And finally, 7 and 2 by 5 is far away, so you can't basically join them. So you have to keep 7 infinity, this open interval, as it is. So your final answer becomes minus infinity minus 5 union minus 5, 2 by 5, I guess it was, 2 by 5, and then union 7 and infinity. Okay, now you are lucky in this case, because minus 3 basically was present in these two intervals simultaneously. Okay, you could have seen some situation like this also, where minus 3 ends here, then you start from minus 2 here. Okay, so then you can't just join these two, you have to separate it. Okay, so these things you have to consider. Okay, these subtle changes that you make at the very end of the problem, that you change some first brackets into third brackets, depending upon whether you want to avoid the problems where you put a 0. So these things you have to look carefully. So I hope that with this discussion, be able to now, if I give you any complicated expression, okay, as many as factors you want, okay, as many as constants are there, as many as different powers are there, if I give you, you will solve it. You will be able to solve it, because this chart is the main thing. Because if I flip this problem, if I say that okay, the problem is this now, what is the change? Okay, nothing. Okay, you said that this is the zone you want your x to be in. Now you will have to say that my x has to be here, because you want it to be negative. Okay, if I say that okay, maybe it's something else, it is strictly bigger than 0, say for example. So if I ask you this, then what will happen? So when you said that x can be 7, so for example, here is another mistake that I have made. X can be 7. Okay, so the original problem that was there, it was bigger than equal to 0, so x can be 7, so this has to be also a third bracket. Okay, so here let me change the answer. Okay, because there is nothing stopping x from being 7, because the problem is, original problem is that this quantity is bigger than or equal to 0. That's why if I just remove the equality now and say that no, I am talking about strictly bigger than 0, then maybe my answer needs to change. Okay, that's the time. So if I, the whole expression, whatever it was, if I go for bigger than equal to 0, this is fine. But if I go for strictly bigger than 0, then these third bracket need to change into a first bracket. So these subtle changes you have to make at the very end of the problem. Okay, it's not much. I have to produce this chart at any given scenario. You have to do it. Okay, now what will happen once you start solving these problems, and slowly making these charts, with time what will happen, your calculation will become faster, and maybe you don't need to make such charts. You just look at the expression, keep your fingers like this, and you just write the final sign. Okay, so for example, initially it was negative, then it became positive. You directly write the positive signs. Okay, But in any case, you have to form this line, okay, this real line, and put your constant values, in an increasing order from left to right. So this part you have to do. You can avoid all this drama when you are, you have gotten your quota of sufficient practice. You can avoid this, slow. But as you are learning for the first time, I had to show you this. Now, this whole process has a name, okay. So whatever expression, okay, I have given you some expression. So this quantity, some power, maybe some quantity, some power, some quantity, some power, then the same thing here. So this expression, okay, and I am asking you for the sign. So what happens? You can write it like this, that plus 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 minus minus plus, right? So once you put all your values, minus 5, minus 3, minus 5, minus 3, 2 by 5, half, 7, okay, you can say that, what was the order again? Plus 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 minus minus plus. Okay. So plus 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 minus minus plus. Okay. So if this is the case, what you can do to represent the plus, you can draw a graph like this. Okay. Not graph. Let me use these words with caution. It's curve. Okay. Because we are not technically drawing the graph of this expression. Okay? You know graphs, how to draw it. So if I give you y equals to 2x plus 5, you know that it will eventually become a line, because you have drawn these graphs in a graph paper. Maybe when you are in grade 8, let's say, it will look something like this maybe. So if I can do x versus 2x plus 5, which is my y, no? This is my x versus y. We can also go for, x versus any expression. No, even if this, the expression is this complicated. Okay, you can then for each x you can put it over here and you get some value, and then you plot those points and you can find some graph. So I am not talking about that graph. Okay, I am just, representing it with a curve where the positive sign, as I know it is in this zone, it is positive sign. We are not particularly drawing the graph of this expression. Okay, that's different. Okay, that is not, today's discussion, because it will be complicated. But as the sign, of the expression when my x was lesser than 5 was positive, why not draw a graph or curve where my curve is above the x-axis? Okay, so it signifies that it is positive. Then again it is positive. Okay, we are not drawing the graph, but we are representing this, positive with this, this drawing just. Then we have again plus, we are representing this plus like this, and then finally you have minus, then you have minus, and then finally you have plus. Okay, so please don't think that at x equal to minus 5 the value of this expression is 0. Okay, that's why I told you that this is not the graph of this expression. Okay, because at x equal to minus 5 we know that 0 is never the value of this whole thing, because 0 is here. So it's a problem. Okay, no way at x equal to minus 5 this expression will become 0. So the curve that we are drawing, maybe it looks like that, okay, at minus 5 it touches the x-axis, so maybe it is 0. It's not that. Okay, so that's why it's not a graph. Okay, it's just a curve, it's a representation, and it's it looks like something wavy, right? So it looks like a wave. That's why the whole thing that we just did for the last god knows how many minutes, this has a name, and this is known as Wavey Curve Method. So to find this wave like curve, we did all this hard work, okay? And our discussion started from what is a set, and from there onwards it slowly came to this point. This is the idea, okay? So now let me give you a brief summary of today's discussion. First we did sets, okay? We did operations, okay? Then I kind of took an example of a set which was mostly the real number, set of real numbers. Then the idea of subsets came, portions of a set, okay? The operations can be done on two sets, okay? Two subsets of a bigger set are also basically two sets only. So these same operations can be done on those subsets. If I take the whole set to be the set of real numbers, the subsets has a different name, okay? We call them intervals, okay? Now you take different operations, union, intersection, complement, difference, whatever. We saw how to draw them, okay, on real line, okay, with this representation of real line. And then I just told you that you can't go for this without changing the direction. And this basic fundamental idea, I used it in a problem, and that problem is known as inequality. You have solved equations before, but maybe inequality for the first time. And then it went on to we saw what is the problem, okay? We saw the detailed way of solving this correctly, okay? And then a shortcut, okay? So there is a long cut which involves taking different cases, the long cut, which we kind of didn't like much, but sometimes we have to do things which we don't like because we have to learn. so this is our shortcut. So we've seen the long cut and then the shortcut. Shortcut basically involved making this inequality, which has some value which is other than 0, to 0, okay? Then from this simple problem we started increasing the complexity. So it will be we started from this simple problem and then slowly start adding complexities, okay? So we kind of, in place of x minus 7 we took 2x minus 7, okay? We may add multiple such factors. We added powers, okay? We looked into the fact that if some quantity is here, it can't be 0, okay? So to avoid that, we saw that how to tackle that, okay? So if something is becoming 0 here, you have to make sure that, and the idea of I mean by drawing them on real line is this. So the first bracket, their types. So basically intervals and their types. Okay. So first bracket, third bracket, third bracket, third bracket, first bracket, third bracket, whatever. Okay. So this is the whole story of this class. Okay. So this lecture basically deals with Wavey curve method and related things. Okay. So that's all for today. See you in the next video.